First example, we have a pretensioned beam. So remember here, read it properly whether it is pretensioned or post-tensioned. Okay, in this case we have a pretensioned beam. The area of the cross section is 150 by 300 and is prestressed with 8 wires of 7 mm diameters each, which are located at 100 mm from the soffit. If the wires are initially tensioned to a stress of 1100 Newton per mm square, calculate the stress at transfer and effective stress after all the losses. Okay, so we have to find here two things. One is the stress at transfer. Second is effective stress after all losses. Okay, what is the effective stress after all the losses? Given is the losses due to relaxation of steel is given, shrinkage of concrete is given, creep coefficient is mentioned. Okay, modulus of steel and concrete are also given. So the first step is draw the rough sketch and note down the given data, that is initial stress, modulus of elasticity of steel and concrete, coefficient of creep. Obtain the modular ratio, that is M, that is the ratio of ES by EC, which we get 6.6 in this. Then next, the area of concrete, which is 150 by 300, we get 45,000 mm square. Then is the value of I, which is BD cube by 12, we get it as 33.75 into 10 raised to 7 mm raised to 4. So now these things have to be done very quickly. So now let's move to the main part, that is the losses. Okay, so firstly let us find the area of wires. Here we have 8 number of wires, each of 7 mm diameter. So therefore the total area of steel will be pi by 4 into 7 square into number is 8. So we get it as 308 mm square. Therefore stress P is equal to the load, pre-stressing force P is equal to area of the wires into the stress, pre-stressing force stress which is applied, that is 1100 in this case, which is the given data. So we get P as 339 kilonewton. So that means a pre-stress force of 339 kilonewton is there, exists. Now next step is, let us find the stresses in concrete at the level of steel, that is Fc or sigma c. Now in the summary, this was the first formula. So we are starting with that summary sheet now, which you have to use. So Fc or sigma c is equal to P by A plus P into E by I, again multiplied by E. So we'll substitute all the values, that is the value of P, value of A, value of I and value of E. Now finding eccentricity and all at this level, you should be able to do it on your own, because the location of the wires is at 100 mm from the bottom of the beam. The beam is of depth 300 mm, therefore center of the beam lies at 150 mm. Therefore eccentricity will be 150 minus 100, which gives you 50. E value is 50. Don't search where E is given. That much of common sense should prevail now at this stage. So now let us first obtain the stresses at transfer. So at transfer, which all losses takes place, that is important. So when your pre-stress force is transferred, there will be, firstly, because of the jacking arrangement, there will be a loss due to relaxation. Secondly, you'll have loss due to elastic deformation. Then you'll have loss due to shrinkage. Okay, so these are the losses which are taking place at the transfer stage. Okay, so loss due to relaxation, loss due to elastic deformation, loss due to shrinkage. These have to be accounted in the first stage. Now, loss due to relaxation, it is given as 35 Newton per mm square. We'll take it directly. Loss due to elastic deformation is nothing but your modular ratio 6.66 into Fc or sigma c, that is the stress in concrete at the level of steel, which we have found out to be 10.04. Therefore 10.04 multiplied by 6.66, we get 66.5 Newton per mm square. This is the loss due to elastic deformation. Then loss due to shrinkage is the given value into ES. Okay, the given value into ES. So when we see here shrinkage of concrete, the given value is what? 100 into 10 raised to minus 6 in the given data. That has to be multiplied by ES, that is modulus of elasticity of steel. Okay, so remember, loss of shrinkage is shrinkage value which is given as 100, or if it is given in terms of percentage, you need to convert 100 into 10 raised to minus 6 multiplied by elasticity of steel. So we get it as 21. Therefore adding all the three, that is 35 plus 66.5 plus 21, we get the total loss as 122.8 Newton per mm square. Therefore this loss needs to be subtracted from the applied stress. Now what is the applied stress? That is 1100. Therefore 1100 minus 122.8 is equal to 977.5 Newton per mm square. That means at the transfer stage, or say in the initial stage, out of the 1100, which is the applied stress, we will have an effective stress of 977.5 Newton per mm square, which is acting. This stress we get after subtracting the losses at transfer stage. Now, next comes your effective stresses after all the losses. That is, during working stress after certain period of time, again we are estimating the losses. So now here also all the losses will be there, okay, which we have taken in the previous case, but values will differ dependingly on which loss we are considering. So first, relaxation loss, which is given, that is at a later stage it is 70. Initially it was 35, at the later stage it is 70. Next, loss due to shrinkage. The shrinkage factor has changed here, which was 100 into 10 raised to 6, now is 300 into 10 raised to minus 6, which is the given data. Now multiply ES to it, we'll get 63 as the loss. Then elastic deformation remains the same, it doesn't change because the formula is same. Then at this stage creep comes into picture. So important thing to be noted is creep losses don't occur at the beginning or say at the transfer stage. They come into picture at the later stage because, as we have studied in the theory, it's a time dependent phenomenon. As the concrete ages, creep comes into picture. Now here they have given the creep coefficient as 1.6. So this we have to multiply by your Fc or sigma c, which is the stress in concrete at the level of steel, into modulus of elasticity of steel. So here, as the creep coefficient was given, we are using that relationship to obtain the losses due to creep, which come out to be 106.9. Now therefore adding all the losses, that is relaxation loss, shrinkage loss, elastic deformation and creep, we get a total loss of 306.4. Therefore the stresses left out after accounting for all the losses will be 1100 minus 306.4, which comes out to be 793.6 Newton per mm square. So guys, here see the difference. Applied stress was 1100, whereas after taking into account all the losses, we have ended up with the value of 793.6. Now if you want to find percentage, what has to be done is 793.6 divided by 1100 multiplied by 100 gives you the percentage loss. Now that's why taking the losses into consideration becomes very important. See, applied was nearly 1100 and effective after taking all the losses is hardly about 800. So we are losing 300 Newton per mm square of stress nearly. Okay, so when we design, it becomes very important for us to take into consideration the losses. So this is your first example in which from the given data, firstly we found out the stress in concrete at the level of steel. Then two things were asked: losses at transfer stage, that is the initial stage. Second is the losses at the latter stage, that is effective losses, considering all the losses which were included in the example. So important thing to be noted here is the creep loss comes into picture in the latter stage, and other three losses, that is relaxation, elastic deformation and shrinkage, are there at the transfer as well as further also they exist. Now one more important thing is at initial stage or at the transfer stage, the relaxation loss is lesser as compared to the later stages. Similar thing happens with the shrinkage, because as shrinkage is a time bound phenomena, as time goes on, the loss due to shrinkage increases gradually, whereas the loss due to elastic deformation remains constant throughout. So this is about the first example. Hope it is clear. You solve. Please get back if you have doubts. If you don't get back to us with your doubts, it will be difficult for both of us further to clear the doubts. Don't say that let the college begin, I'll come and sit in the cabin. You will also have a hell lot of work when the college reopens. We also will have a hell lot of work with when college reopens. This is the time when you also have time, we also have time. I am requesting individually to come back if you have doubts. Okay, because accessing these things, revising further is very difficult. I doubt whether we'll be able to solve this again in the classroom or no. This can be accounted as continuous learning, and might be this topic may not be discussed again in the classroom. So now